This is a practice problem where we get to utilize selection to make predictions about our future allele frequencies. In this problem, we're looking at Daphnia populations. In this population, we identify 5,625 blunt helmet individuals and 3,750 heterozygotes. We have a total population size of 10,000. I ask the question, what is the predicted allele frequencies in the next generation? This predicted allele frequencies tells us that we're going to calculate P and Q. Now, in this problem, I tell you this number, the selection coefficient. So in the problem, our selection coefficient is 0.15. We're trying to predict our allele frequencies, so we'll use our equation P prime equals P divided by 1 minus SQ squared. In order to calculate our new allele frequencies, we must first have our P and Q values. To do this, we repeat the methods that we used when calculating if a population is in a Hardy-Weinberg equilibrium. So, we're looking at our observed genotypes. I'll use H, big H and little h to represent our alleles. So in this population, we observed a blunt phenotype, which is the recessive phenotype. We had 5,625 individuals. We had 3,750 heterozygotes in a population size of 10,000 individuals. That means that we have a total of 625 homozygous dominant individuals. We don't need to calculate genotype frequencies at this point because we only want to calculate our predicted allele frequencies. So using this information, we can calculate our observed allele frequencies, big H, which is also equal to P. This is 2 times 625 plus 3,750 divided by 2 times 10,000. I have 5,000 in the numerator, 20,000 in the denominator for an allele frequency of 0.25. I'll repeat the process to calculate our recessive allele frequency, little h, which is also Q. Now I have 2 times 5,625 plus the number of heterozygotes divided by 2 times our population size. 15,000 in the numerator, 20,000 in the denominator for a recessive allele frequency of 0.75. Now we have our P, we have our Q, and we know S because it's given in the problem, so now it's just plug and chug. P prime is equal to 0.25 divided by 1 minus 0.15 times our Q squared, 0.75 squared. Using a calculator, I get 0.25 divided by 0.9156 for a new predicted dominant allele frequency of 0.273. We also want to calculate Q prime because I ask for the predicted allele frequencies. This is 1 minus P prime. Substituting gives me a new recessive allele frequency of 0.727.